Let us continue nitrogen family. In the nitrogen family, chemical properties of PCl5, let us discuss. In that we will take metal, silver. Silver is heated with PCl5. What will happen? PCl5, in which axial chlorine is weaker than equatorial chlorine. Therefore, axial PCl bond breaks. So PCl5 becomes PCl3 and Cl2. Cl2 reacts with silver to give silver chloride. So and so reaction takes place. Then metal tin we will take, metal tin with PCl5 on heating. PCl5 on heating decomposes to give what in the sense PCl3 and Cl2. PCl3 and Cl2. Because axial PCl bond is weaker than equatorial PCl bond. Therefore, PCl3 and Cl2 will be produced from this. Cl2 reacts with the tin and gives a stannic chloride, SnCl4, stannic chloride. So, tin is having +4 oxidation number here. Stannic chloride we are getting. So, we'll take a PCl5 2 times, PCl3 2 times. Okay, like this possible. Next, we will see PCl5 gas and PCl5 solid. We'll see. PCl5 gas. What is the structure of PCl5 gas? That we will see. Phosphorus is the central atom. 5 chlorine atoms are the surrounding atoms. 5 chlorine atoms are the surrounding atom. It is PCl5 structure. PCl5 gas is covalent compound. Now we will take solid PCl5. Solid PCl5 is ionic compound. This ionic compound contains cation PCl4 plus, anion PCl6 minus. Now we will see this ionic compound. We will take PCl5 2 times. We are taking PCl5 2 times. Now this phosphorus is providing vacant 3d orbital. This Cl, this Cl is having lone pair. This Cl is having lone pair. This Cl is contributing lone pair to this vacant orbital of phosphorus, while this bond is shifting like this. So what we will get, that we will see. In this phosphorus, only 4 Cl will be there now. Only 4 Cl will be there. This phosphorus is losing the bond, therefore getting positive charge. Next, this phosphorus is having 5 Cl. 1 Cl it is getting additionally. 1 Cl it is getting additionally. Therefore, this phosphorus is having 6 Cl. This phosphorus is contributing vacant orbital and getting bond from Cl. Therefore, this phosphorus is having what charge means negative charge. Phosphorus is having negative charge. This is only PCl6 minus octahedral, PCl4 plus tetrahedral. So, solid PCl5 contains cation PCl4 plus and anion PCl6 minus. Therefore, solid PCl5 is a ionic compound, we can say. Next, we'll see about oxo acids of phosphorus. The first one is hypophosphorus acid H3PO2. How to prepare H3PO2? That we will see. We'll take white phosphorus. White phosphorus we are taking. To this we are adding sodium hydroxide solution and the solution is boiled. What happens means white phosphorus becomes phosphine and sodium hypophosphate. Sodium hypophosphate is obtained. This sodium hypophosphate on treating with the dilute HCl, we are getting a H3PO2. Hypophosphorus acid we are getting. Now, in the H3PO2 structure, if we see, structure of H3PO2, we can write like this. Here, this pH bond is having reducing hydrogen. This hydrogen is reducing hydrogen, not acidic hydrogen. It is what means reducing hydrogen. This is also reducing hydrogen, not acidic hydrogen. This OH group contains hydrogen. It is acidic hydrogen. Therefore, this H3PO2 can act as a reducing agent. Here, oxidation number of phosphorus is +1. Okay. Now, we will take silver nitrate. From silver nitrate, we will take Ag+. This H3PO2 will take This H3PO2 act as reducing agent. Therefore, Ag plus undergoes reduction and becomes Ag. This H3PO2 undergoes oxidation. That means the phosphorus plus 1 undergoes oxidation to maximum oxidation state, that is H3PO4. Here phosphorus is plus 5. Phosphorus plus 1 is undergoing maximum oxidation state equal to its group number, that is plus 5. Okay, so Ag plus is converting into Ag. H3PO2 is converting into H3PO4. The plus 1 phosphorus is converting it to maximum oxidation number plus 5 phosphorus. So, next, mercuric cation we will take. Mercuric cation becomes mercurous ion. Mercurous ion means we have to write in the dimeric form. We have to write mercurous ion, you write in the dimeric form. Oxidation state of mercury is how much means plus 1 we can say. So mercuric undergoes reduction and becomes what in the sense mercurous ion. Mercurous ion undergoes further reduction and becomes mercury, while H3PO2 undergoes oxidation and becomes H3PO4. Okay, so therefore H3PO2 acts as reducing agent. Here plus 1 phosphorus becoming plus 5 phosphorus, H3PO4, Ag plus converting into Ag, mercury converting into mercurous, mercurous into mercury possible. So then H3PO2 undergoes disproportionation on strong heating. This plus 1 phosphorus becomes least oxidation number minus 3 phosphorus in phosphine, and highest oxidation number, that is H3PO4, here plus 5. P plus 1 is going for least oxidation number minus 3 reduction, plus 1 converting into highest oxidation number plus 5 oxidation. That means disproportionation is possible. Next acid we will take phosphorus acid, that is H3PO3, phosphorus acid H3PO3. That preparation we will see. In this preparation, PCl3 undergoes hydrolysis to give H3PO3. P2O3, phosphorus trioxide, undergoes hydrolysis to give H3PO3. Next, this H3PO3 on strong heating, what happens means this phosphorus plus 3 is converting into least oxidation number phosphorus phosphine and highest oxidation number plus 5 as H3PO4. H3PO4. So H3PO3 undergoes a disproportionation reaction to give PH3 and H3PO4 we can say. Next, this H3PO3 structure we will see. H3PO3 structure is so and so. Now here reducing hydrogen is present, therefore H3PO3 acts as a reducing agent. This converts Ag plus into Ag. Okay, Ag plus is converting into Ag by H3PO3. Here H3PO3 is having plus 3 oxidation number phosphorus. It is converting into highest oxidation number phosphorus, that is plus 5 as H3PO4. So H3PO3 undergoes reduction to give oxidation. It is undergoing oxidation. It is taking one oxygen and becoming H3PO4. Ag plus undergoes reduction and becomes what in the sense Ag we can say. Now H3PO3 acts as reducing agent because reducing hydrogen is present. This H3PO2 also acts as reducing agent because reducing hydrogen is present. Which is better reducing agent means H3PO2. It is having higher reducing nature because 2 pH bonds. It is having lesser reducing nature because 1 pH bond. Okay. Next we will take a H3PO4 we will take orthophosphoric acid H3PO4. How to prepare H3PO4 in the sense P2O5 on hydrolysis gives H3PO4, PCl5 on hydrolysis gives H3PO4. Okay. Next preparation, white phosphorus we will take, corn nitric acid we will add, concentrated nitric acid, and it is heated. What happens means phosphorus gives H3PO4, concentrated nitric acid gives NO2. Concentrated nitric acid will give NO2 when it acts as oxidizing agent. Okay, So white phosphorus becomes H3PO4, corn nitric acid becomes NO2. Concentrated nitric acid on oxidizing agent, when it acts as oxidizing agent, it will become NO2. Similarly, corn sulfuric acid, when it acts as oxidizing agent, it will become SO2, sulfur dioxide. Okay. Then H3PO4, another preparation will take bone ash. Bone ash will take. Bone ash contains calcium phosphate. Bone ash contains calcium phosphate, Ca3PO4 twice. It is treated with concentrated sulfuric acid. It is treated with concentrated sulfuric acid. What happens means this phosphate takes H plus from here and becomes H3PO4. Calcium and sulfate becomes calcium sulfate. Okay. Then this H3PO4 on heating, what it gives, that will see. H3PO4 on heating, what happens means it gives a H4P2O7. H4P2O7. That means double this and remove water. Double this and remove water. You will get H4P2O7. Sir, this is possible at 250 degrees Celsius. At 250 degrees Celsius, it is possible. Then this H4P2O7. This H4P2O7 on heating to 320 degrees Celsius. What happens means it loses water. It loses water. What is the remaining? H2P2O6 divide by 2. You will get HPO3. Metaphosphoric acid you will get 2 times. Okay. This HPO3 on heating to, this HPO3 on heating to 600 to 700 degrees Celsius. 600 to 700 degrees Celsius. What happens means we are getting it is losing water. Okay, 2 times HPO3 you take. Remove water. What is the remaining? P2O5. Phosphorus pentoxide we are getting. Therefore, so H3PO4. This H3PO4 on heating to 250 degrees Celsius, it gives H4P2O7. Then, when it is heated to 320 degrees Celsius, we will get metaphosphoric acid HPO3. When it is heated to 600 to 700 degrees Celsius, we will get phosphorus pentoxide P2O5. Next we will take a pyrophosphorus acid. We will go for pyrophosphorus acid, that is H4P2O5. This preparation we will see. We are taking PCl3 and H3PO3 on heating gives H4P2O5. This H4P2O5 is called a pyrophosphorus acid. That means take H3PO3 2 times, remove water, you will get this. So we have taken H3PO3 one time, PCl3 on hydrolysis gives H3PO3, therefore we are getting H4P2O5. Okay, next we will see hypophosphoric acid, H4P2O6. Hypophosphoric acid we will see. This hypophosphoric acid, how to prepare? Take red phosphorus, treat with alkali, heat with alkali. We are getting hypophosphoric acid, H4P2O6 we are getting. Next, how to get metaphosphoric acid, HPO3, that we will see. That is, we are taking phosphorus acid, H3PO3. It is treated with bromine. We are getting what in the sense metaphosphoric acid we are getting.